Let's talk about the meaning of an overall significance test and talking through the steps. So let's suppose, let's say you even had something like 5 variables in your model and you finish and absolutely nothing is significant. So there's a variety of reasons that that can happen, but let's suppose that's what you have occurring. And so just before you look into some other possible explanations, you might just want to check, are all my variables taken as a group, explaining why? So overall significance always would mean that every single slope coefficient is set to 0. And note that I'm saying slope coefficient, I'm not saying the y-intercept. And the alternative hypothesis is at least one is non-zero. So let's imagine we're using some given level of significance. This follows a F distribution as well as when we do joint significance. However, we have a different test statistic. It won't work to run a restricted regression with no slope coefficients. This one is based off some underlying results from analysis of variance. Well, all regressions are based on that, but this particular F test calculation, we only need the r squared from the equation that we've estimated. So in the numerator, notice k is the number of variables that we have, but k is always representative, this portion is always representative of the number of restrictions. So if we want to look at how many restrictions we had 1, 2, 3, 4, 5 equal signs means we had 5 restrictions. We would have r squared here, we would have r squared here, we'd have whatever our sample size is. We have 5 restrictions, and then the -1 here is for the additional fact that we estimated a y-intercept as well. So our F critical is skewed, starts at the origin, and what we're thinking about is that it has numerator degrees of freedom equal to the number of restrictions, which comes from this numerator. In terms of numerator, we're thinking of above that. And then the denominator degrees of freedom comes from n minus k minus 1, which is this. So we would use those two to find our F critical, and we would use whatever tail I said. Let's think about 1%. Sorry, that's a mess. Why won't it erase? Oh, there we go. Okay, so that's 1%. And then wherever our F test comes in, and since I call this the 6-inch hurdles, oftentimes if your model has anything reasonable in it, you'll be able to reject this null. But let's say your F test comes in here. Let's just remember the p-value that comes on the output in the bottom row of R. This overall significance is always shown on the bottom row. It shows you the F statistic, it shows you numerator degrees of freedom, it shows you denominator degrees of freedom, and it shows you the size of the p-value. So since that all comes out automatically, this test is easier to do by seeing, is the p-value smaller than alpha? If so, then we reject the null. And rejecting the null hypothesis means at least something in my model is explaining the variation in y above and beyond what simply using a constant would be able to do to explain y. So reject the null would mean overall model is significant, and at least one of our slopes are significantly different from 0. So even though in a t-test we're not necessarily seeing them significantly different from 0, in our f-test we can detect it. Now notice this also means if you've done a t-test and it already has something highly significant, then that alone should make you reject the null in an overall test of significance, because you have something that's significant and it would show up in this f-test. So using the overall significance test is most useful when you are not having significant coefficients. But if you are having one or more significant coefficients, you can find that in your t-test as well as having this test reject the null.